In today's lesson, we are going to be solving trig equations. These equations at first, they can look pretty intimidating, but all it is it's mixing algebra and trig together. You're just treating it like you're solving an algebraic equation, but there's trig involved. So it starts out just isolating the trig expression. So this is just kind of like isolating the variable. So first example, 6 times tangent of x is equal to -2 square root of 3. Okay, so our goal is to solve for x. So let's divide both sides by 6. So now I have tangent of x equals, this can simplify, so negative square root of 3 over 3. Okay, so we should, knowing the unit circle, figure out at what radian do we get negative square root of 3 over 3. Now, I should have mentioned this at the beginning. For today's lesson, we are just going to keep our answers in the range from 0. So theta is going to be, or x, will be 0 to 2 pi. So technically, tangent of x will equal this value at an infinite number of locations because the circle just keeps going round and round and round. But let's see, tangent is negative in quadrant 2 and quadrant 4. And it's always the negative square root of 3 over 3 at the pi over 6 locations. So our answer, x equals both 5 pi over 6 and 11 pi over 6. Okay, let's do one more example in that same category. So this time, -2 minus the square root of 3 over 2 equals -1 plus cosine of theta. All right, so this looks a little complicated. What caught my eye first is on this left. So can we simplify that at all? We can divide both of these by 2. So -2 divided by 2 is -1. And then negative square root of 2, or square root of 3 divided by 2, so minus square root of 3 over 2 equals -1 plus cosine of theta. And then if we add 1 on both sides, the 1's just cancel out. So now I just have cosine of theta. So what radian gives you negative square root of 3 over 2? So cosine is negative square root of 3 over 2 at 5 pi over 6 and 7 pi over 6. So theta equals both of those values, 5 pi over 6 and 7 pi over 6. Okay, the next type of solving is going to involve taking square roots. So you don't need to write this part down, but if we have a trig function that's being squared, that's where we will put the squared next to the trig instead of after. We don't want to do this because then it looks like it's cosine of x squared, which it's not. Technically, another way to write it would be in parentheses, cosine of x, and the whole function is being squared. So these are equivalent, but what you're going to see is that top. That's how we usually write when we're squaring trig functions. So here's the first example. 5 times cosine squared of x equals 3 plus cosine squared x. So let's think about this. Let's just, if we're solving an algebraic equation, this is just like we have variables on both sides. Let's get them on to one side. So if I subtract a single cosine squared, now I have 4 cosine squared x equals 3. So then you can divide by 4. Cosine squared x equals 3 over 4. And then we can square root both sides. So we'll have regular cosine of x is equal to plus or minus square root of 3 over the square root of 4 is square root of 3 over 2. Okay, so where's cosine? Let's see, positive square root of 3 over 2 and negative square root of 3 over 2. So we're going to have 4 solutions to this one. It's basically all the pi over 6's. So the value of x is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And that is because for this lesson, we are sticking to that original domain of 0 to 2 pi, because technically these would keep going on and on forever, as they would just continue to have coterminal angles equivalent to that. Okay, let's do another one of these examples where we have to square root the function. Okay, this example, negative 2 minus 4 times tangent squared equals negative 3 minus 3 tangent squared x. So at a quick glance, this looks complicated, but this is just basic algebra. So let's see, I could add this 3 on both sides, and I could add 4 tangent squared on both sides. So this cancels, so then I have 1 equals 1 tangent squared x. And then square root both sides. So I'm going to bring my tangent to the left, so then tangent of x is equal to plus or minus 1. Okay, so where is tangent 1? Tangent is 1 at the pi over 4's. And negative at these pi over 4's. So because it's plus and minus, we have to include all 4 answers. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, last type of example is when we have a common factor of our trig functions. So here's our first example. 0 equals square root of 3 tangent of theta plus 2 tangent of theta cosine of theta. Okay, so we have 2 terms, and both of those terms have a common trig function. So we can factor that trig function out in front. So I can have tangent of theta, take it out, divide it out of both terms, so you're left with square root of 3 plus 2 cosine theta. Now, this is, think about solve by factoring. When we have quadratics, it's set equal to 0, and we would have these 2 binomials. And then we would just set each of them equal to 0 and solve. This is in that same format. 2 things being multiplied together to get 0, break it up. Either tangent of theta equals 0, or square root of 3 plus 2 cosine of theta equals 0. And now let's solve both of them. So when is tangent 0? Tangent is y divided by x. So tangent is 0 at 0 and pi. So theta equals 0 and theta equals pi. Okay, let's finish solving this right one. I'm going to subtract square root of 3, divide by 2. So negative square root of 3 over 2, and this is cosine. So when is cosine negative square root of 3 over 2? That is at 5 pi over 6 and 7 pi over 6. We've had a lot of the pi over 6 ones in this lesson so far. So 5 pi over 6 and 7 pi over 6. So the original equation has 4 solutions. Okay, here will be the last example of this lesson. So tangent squared of x equals negative square root of 3 times tangent x. So we have tangent on both sides, so what we can do is get tangent all onto one side. So I'm going to add this right side over to the left. So then I'll have tangent squared of x plus square root of 3 times tangent of x equals 0. And I have two terms. I can factor a tangent out, which leaves me with tangent x and then plus the square root of 3 equals 0. And now same thing as before, set both of these equal to 0. Oh, so we get tangent of x equals 0 again. So that is again 0 and pi. But now I have tangent of x plus square root of 3 equals 0, or tangent of x equals negative square root of 3. So tangent, let's see, tangent is negative in quadrant 2 and 4. And then square root of 3 is at the pi over 3's, so here and here. So 2 pi over 3 and 5 pi over 3. So that original equation has these four solutions. So there's your full video on solving some trig equations. Good luck.